fostering careers in microbiology and showing the very different menus in which microbiologists work. We have 3 presentations planned. They will deal with the topic of careers in technology transfer, careers in industry, and careers in law enforcement. Our first 2 speakers are here. Hopefully, the third one will also arrive, but I thought that we should start and we should, to keep in time, our first speaker is Dr. Melnikov from the Wistar Institute in Philadelphia, and the title of her presentation will be Technology Transfer, Bridging the Gap from the Lab Bench to the Business Community.
I was asked before I start to give you a little bit of background on myself and how I got here. I actually have a bachelor's in biophysics and microbiology. I worked a number of years at the bench, then went back and got my PhD. So I guess I've been non-traditional from the start. After which I worked in industry for a while. And now for the past 10 years, I have come back to academia, where I am the Director of Business Development at the Wistar Institute. For those of you who don't know Wistar, we're a private medical research institute in Philadelphia, and while our faculty do not have teaching responsibilities, we are primarily funded by the federal government, mostly by NIH, and that underlies a lot of what I do in tech transfer. Now, let's see. Does this work? No. Okay. Do you know how to change the slides? Oh, no, that's not working. I'm clicking the mouse. Wait. No. Ah, okay. Left button. Okay. Today I thought I would cover a couple of questions about a career in technology transfer. And I think probably the first question for those of you who are researchers or work in the clinical lab is, what is it? And so we're going to go over what is tech transfer, what does a person who is a professional in tech transfer actually do, and how would you then go and get training and learn about opportunities in this field. So let's start a little bit about what is tech transfer. And I'm going to I thought the easiest thing was I went to our website, and my office is called the Office of Business Development. Tech transfer occurs in universities. The offices can be called business development, can be called technology commercialization, can be called tech transfer. So they have different names. But the mission of my department is to promote the commercialization of inventions that are discovered at Wistar for both society's use and benefit, and as well as to generate income to support further research and education at the Wistar Institute. Those of us who are in tech transfer, we work at a variety of locations, including universities, research institutes such as mine, or there are also many professionals, and you'll hear about some very interesting training opportunities within the federal government. Additionally, tech transfer professionals may come from or go to work in industry. I actually had worked at SmithKline when it was SmithKline Beckman, so I think that's 3 mergers ago, and before I was at the Wistar Institute, and that is very common. Also, many of my colleagues have gone from the academic tech transfer to business development in industry. So what does the Tech Transfer Office do? What are our key responsibilities? And I've laid them out into 4 areas. And I view this, and I did not make this into a graphic, as kind of a pyramid, where the base of the pyramid is to identify new proprietary technologies. What is a proprietary technology? They can be a patentable invention, a proprietary material, or copyrightable matters. So an invention can be you identify a new gene related to antibiotic resistance. You identify a new way of growing something. These are patentable inventions. Proprietary materials can actually be organisms. We at Wistar have a lot of monoclonal antibodies. 30 years ago, we're one of the leaders in developing monoclonal antibodies against tumor, and we still have many, many monoclonal antibodies that we license. And these have no lifetime if they are managed properly. And the third would be copyrightable materials such as software, publications. The next step in the pyramid, so you have your base of your new technologies, is to really protect these technologies. And we protect them by a variety of legal agreements that we spend a lot of time dealing with, as well as filing and prosecuting patent applications. Then once we have a patent or a technology, the next step in the pyramid is really to market the proprietary technologies, to identify for-profit companies that will license them. So these are our licensees. And then the final step in this technology transfer is negotiating license agreements and research agreements for commercial development of the technologies. What is very interesting about technology transfer is that it really incorporates a variety of disciplines. And what I always find very interesting about my job is that I'm really working at the interface between science, business, and law. And to do the job well, you will wind up learning a little bit about each of these disciplines and trying to figure out how to balance the needs of these different aspects of your relationships. Now, tech transfer as an industry, and it is an industry, got started in 1980 with the passage of what's called the Bayh-Dole Act. And this act was sponsored by Senators Birch Bayh and Bob Dole. And before 1980, if you worked at an institution and you had funding from NIH or FDA to do your research, and you invented something, it technically belonged to the federal government. And in fact, I have in my office some very old license agreements where every time we wanted to license something that was developed with federal funds, we had to go back to the government and get them to sign us the right to do that. And we licensed back then some very important technologies, including the rubella vaccine that every one of us gets now when they get MMR. So, but in 1980, the Bayh-Dole Act came up with some very key provisions that really, as I said, established the tech transfer industry. First of all, this act said that if an invention arises out of federally funded research, the institution, the university, the academic institution, or the government office where that research took place has the right to get ownership of that invention. So once a scientist at a university now discovers something with federally funded research, you don't have to go back to the federal government. The scientist doesn't automatically own it, which actually is the case in some countries outside the U.S., but the ownership now will reside with the university, and the university can turn that back to other groups, but right now it's primarily with the university. So once we have these technologies, then the Bayh-Dole Act encouraged us to collaborate with companies to commercialize the inventions. The goal here is not to let the technology sit on the shelf, figuratively speaking, but to really get it out there to the companies to develop it into commercial technologies that are going to really help everyone in the U.S. and more importantly today around the world. Next, it encouraged universities to file patents on any inventions that we own, and also to give licensing preferences to small businesses. Under the Bayh-Dole Act, the federal government retains a non-exclusive license to practice its patent and also retains what is called march-in rights. And the issue of march-in rights is something that that companies that are not familiar with U.S. tech transfer get concerned about, which says if there's a national health emergency, the government can come in and take over your technology for the public good. And while it is always possible that that could happen, I will tell you, in 27 years, the government has never exercised those marching rights. What is also very interesting about the Bayh-Dole Act, and this wasn't appreciated when it was passed, is it's really become very successful, and I'll talk about that in a few minutes. And as a result, similar acts have been passed in other countries. The United States has really become the world's model for how to get technology out of the university and into the clinic and into patients' hands. So 25 years later, these statistics are from 2005. Where are we today with tech transfer? Based on a survey conducted by Autumn, and I'll tell you about that in a few minutes, from 228 academic institutions. These institutions collectively receive more than $42 billion in R&D funding, and that's primarily from NIH, other government agencies, as well as corporate sponsorship. These 228 institutions are responsible for over 17,000 inventions that were disclosed by their faculty to the Tech Transfer Office. As a result, we filed over 15,000 new patent applications. But the real proof is in what happens at the commercial side. And as a result of technologies developed at academic institutions, in 2005 alone, over 500 new products were introduced into the market. Over 600 new companies were created. And today, as of that date, 28,000 active licenses were maintained by institutions. And in 2005, almost 5,000 new licenses were signed. My institution, the Wistar Institute, we're relatively small. In 2005, we probably received less than $40 million in research funding. During that time, we signed about 15 license agreements, had 100 license agreements under active relationships. So institutions such as mine, this is a very, very active field. And of particular relevance, since this is a career development forum, is that technology transfer offices are still growing. And in 2005, these 228 academic institutions had almost 1,700 full-time people working there, half of whom are licensing professionals. So this is an area where there is still a considerable growth and really need for people very bright people who have good science backgrounds and are ready to learn the other parts of this industry. So what exactly do we do at a tech transfer office? I kind of said, well, here's kind of generally what we do. But I'm going to break it out into 5 areas. Now, actually, just to let you know, my husband likes to summarize my career in 2 sentences. He said, well, she used to play with mice for a living, and now she goes to lunch for a living. But it's a little more complex than that. What do we do? Well, first of all, and this is very important, we work with our scientists to identify new inventions that could be a technology with commercial potential. We spend a lot of time preparing and negotiating agreements to protect and develop new inventions, and I'll talk a little bit about that. We manage patenting of new inventions. We find licensees, and then again, we negotiate option and license agreements. So I think you'll see here the interaction between the market, the license, the business, and the science. So our first, and in any, let's see if I can go, okay. In any given tech transfer office, you're going to find all of these functions going on. If it's a large office, there are people who will just do the job of working with the scientist. There'll be other people who just do agreement negotiations. So, but in a small office such as mine, everybody does a little bit of everything. So let's talk about identifying new inventions. A very big part of this is outreach and training to your faculty. A lot of people, how many of you have ever had an invention that you thought was patentable? A few, okay. All right. How did you learn about it? I mean, did you just come up on your own, or did somebody from the tech transfer office work with you? Well, this is kind of what we do. We have to outreach to faculty and really explain to them, you know, what can possibly be a new invention. And then the goal of that is to get the faculty to come and talk to you, either formally or informally, in what's called an invention disclosure. And then we review these disclosures to determine the potential for a patentable and a marketable invention. So what's an invention disclosure? If you're working with an organism and you identify some gene that within that organism that hadn't been known, that could very possibly, now that's certainly a very good publication, but then what do you do with that gene? Can that be used for diagnostics? Can it be used for a target to develop new antibiotics? These are the types of things that when you work with the tech transfer office, you think about your results in terms of what types of commercial potential are they going to have. And part of our job is to train you, to just open you to think that way. I also spend some time reviewing manuscripts for patentable inventions. And for purposes of patenting, it's very important that the manuscript or the invention in the manuscript be identified before publication. Otherwise, you will lose certain patent rights. The really key skills in doing this part of the job is having a fabulous understanding of the science. Not only for just looking at what's in a publication and thinking about what the applications can be, but also when you're talking with these scientists, you're talking with your peers. And if you understand the scientist, they're going to be more inclined to talk to you about what they're doing. And that's where you may find out some new invention that hasn't been published yet that could be in the works. Additionally, you have to have some knowledge of the market. For example, do we really need a new antibiotic for gram-negative infections or new ways to diagnose glioblastoma? And we can talk about this a little bit. And you also, to understand the market and evaluate it, you should also know how to complete some online research on who is working in the field. And as I mentioned a few minutes ago, really interacting with and getting the support of your faculty inventor is really critical in this process. So so that's one aspect, and that for anybody who has any interest in science this is a lot of fun and a lot of creativity. The next is preparing and negotiating agreements. And I mentioned that we need to protect our inventions. And some of the ways we do this are through agreements. All right. Very often our faculty want to collaborate with somebody and they want to send them a transcript, a gene, an antibody, a cell line that they have developed. Well, to protect these materials, remember these are proprietary research materials, they are commercializable technology. My office handles what are called material transfer agreements. And my guess is many of you have dealt with these material transfer agreements. If you've gotten materials, I'm seeing a few heads nodding, good. Additionally, if somebody wants to talk to somebody in industry, or actually sometimes even, usually in industry, about their research, and we haven't really filed a patent application, we will execute what's called a confidentiality agreement. There are a lot of reasons to sign confidentiality agreements, but for the University Tech Transfer Office, the most important reason is to be able to retain the ability to file patents on early research. So again, if you want to file a patent and the research has been disclosed, you lose certain patent rights. But if the research is disclosed only under a confidentiality agreement, then you do not lose those patent rights. So that is our reason for filing confidentiality agreements. I'm not going into the paranoia of someone's going to steal my idea, because we're an academic institution. We believe in open collaboration. But as I said, it is important for us to balance that with the need to maintain proprietary information as proprietary. Additionally, if you work for the federal government, NIH, you will work on a lot of what are called CRADAs, Cooperative Research and Development Agreements. In my office, we work on research collaboration agreements. These are when one of our faculty wants to work with somebody from industry. And so we have these collaboration agreements, and they're a little different than NIH grants because there's a lot of language over who owns what and who can do what with what. The real goal out of all of this is to identify and negotiate license and option agreements. And in our role in terms of negotiating these agreements, we do this a lot in partnership with legal counsel and our contract offices. Now, another thing we do in tech transfer, I talked a little bit about patents, is we really manage the patenting of new inventions. And so what we do is we'll work with our patent counsel and the inventor on the preparation of new patent applications. A lot of this is to really figure out what is patentable and what is not patentable. Has the invention already been patented? Has the invention already been published? Even if no one's patented something, if it's been published, that's going to limit your ability to patent things. And this is where some of the creativity really comes in. If you have something that has potential, how do you come up with what is really new, but that has not yet been patented or published? What we also, when we work with a scientist, is we really try to figure out what are the potential uses of the invention. Somebody comes to me with a new gene sequence. That's very interesting, but what would we do with it? Can I use it to diagnose? Can I, if this is a gene that's mutated in certain cancers, can I use it as a diagnostic for cancer? If it's a bacterial gene, can I use that as a diagnostic for a resistant bacterium? Is it a research tool? Is this something that, we want to license to Sigma and have it available in all your catalogs? Is this something that's going to have therapeutic potential? Is it something that can be used to make a vaccine? And this is where you really want to integrate your knowledge of the science, the business, and what's patentable to really figure out what can you do here with this technology. Additionally, patent attorneys are attorneys and they charge fees, and so an important part of our job is really managing the costs associated with filing and prosecuting patents. That's just managing our budget. The next thing we do is finding licensees, and that's marketing, okay? One of the most effective ways we market is through our website, www.wistar.org. Also, I spend a lot of time going to meetings and identifying and building up, I guess these days, a BlackBerry instead of a Rolodex of contacts in industry who may be interested in licensing our technology. At Wistar, our focus really is in cancer research and vaccines. So a big part of my job is knowing who's doing what in these two fields. So when a scientist comes to me and has something that may have commercial potential, I know where to go with it. I spend a lot of time doing presentations at business-oriented meetings, and these are the biotech industry meeting, which was just 2 weeks ago in Boston. About 25,000 people from biotech companies all over the world descended on Boston. There are many business partnering forums that people go to, and also the Association of University Technology Managers, which is the Tech Transfer Professional Society. And then I'm going to let you all in on what I call the big secret of marketing technologies. And that is that the best licenses and the best research agreements don't really come out of my department's work in marketing. They really come from scientist to scientist collaborations. They come from scientists seeing something that one of our scientists has published, a scientist at a company, or scientists at a meeting talking to one of our scientists and going, oh, you know, what you're doing may very nicely relate to this research program that we've got going on. So the same types of interactions that you're having going on every day here at your poster sessions are also the best way to market new technologies. So once we find a licensee, then my job is to really negotiate the license agreement. And when I do this, I really think about three aspects. There are the business issues, there are the academic issues, and the other issue is who is the licensee and what are they ultimately going to do with this technology. And what I am keeping in mind is this is something that was developed with my tax dollars. My office is the steward of this, and my goal is to get it commercialized in a way that is going to really help mankind. I don't know anybody who goes into research and stays there because they just want to make money. They're doing this because they really want to help people. And if something just stays in the lab and never gets out to clinical trials or to other researchers, then it's not going to help mankind. So this is always very important in my mind when I'm negotiating a license agreement. That doesn't mean I'm going to be a pushover on the business issues. I mean, I have a job there. But really, you know, it's very important to make sure the technology gets out there for the public good. So when some of the things we think about, how is this person going to be using the technology? It's what's called the field of use. So if I have a gene and I license it to company A to use in diagnostics, then I can license it to company B to develop new therapeutics, and to company C to make research tools. And and all of these are complementary, and all of these are different aspects of getting the technology out there for the public good. Do I want to grant what's called an exclusive license or a non-exclusive license? If I am going to be, for example, licensing something to Cubist, and you'll be hearing from my colleague from Cubist soon, they're going to be, what I am licensing to a company, a drug company, is the right to spend lots and lots of money to develop the technology. When I license something from academia, it's either never been in a clinic, we've cured mice, but that's it, or it's maybe been in a phase 1 clinical trial. And so when you're licensing something for a drug development, the licensee is almost always going to want an exclusive license because they are putting a huge investment in this. And I'm not going to go into the philosophical and issues, but they want to protect their investment. Okay? If I'm licensing something to BD Pharmagen or Sigma or Biorad, there it's for research use, and my goal is to really get it out as broadly as possible to all the researchers. So I'm almost always going to license something non-exclusively. And these are some of the issues strategic issues that you consider when you negotiate a license agreement. Tying into this are financial terms, what are the fees, what are the royalties. A very important aspect of licensing is sub-licensing. What happens if the company wants to partner with somebody else? How do we handle all of that? And these are all the types of things that when you're negotiating a license agreement, you spend a lot of time considering. And it's almost like a chess game. When I am negotiating a license agreement, I am always thinking, what is this licensee going to do? Are they going to partner with somebody? Are they likely to be acquired by a big company? And if so, what is the implication as to what is happening to this technology? So this is a part of the negotiation that I find very fascinating because you really have to think strategically. What next? What next? What if? What if? And do your best to get all of those terms covered in your license agreement because in 5, 10, or 20 years, it could come back to haunt you or your colleagues. There are also several academic issues. Remember, my office manages patenting. Well, who handles the patents? What about publication and continuing academic research? This is critically important, and this is something we always make sure we get in our agreements. What about follow-on research? Who pays for it? Who has the rights to the inventions? And who are we licensing to? Are we licensing to an existing company or to a foreign company? Remember, the Bayh-Dole Act says I should be giving preference to early stage or small U.S. companies. But the reality of it is a lot of the licensing that I do today is to vaccines for diseases that are really only problematic in the developing world. So I'm spending a lot of time licensing to companies all over the world. Are we licensing to a startup or to an existing company? And a licensing to a startup is a whole specialized area of technology transfer that I'm not going to get into. I'd be happy to talk about it one-on-one. But that is a whole area where you take a technology and you actually form a new company around it. And that requires certain special skills and characteristics and some special level of entrepreneurship. Now, before I go on to, what else is relevant for tech transfer? When I was talking about this presentation to some of my colleagues in the patent field, they said, please tell them about being a patent attorney. We really need more good biotech patent attorneys. So I promised my colleagues in the patent field that I would include that. So another career option is becoming a patent attorney or a patent agent. And a colleague of mine who has trained many patent attorneys said, here's my most important characteristic, is I need somebody who has a passion for science. Not somebody who thinks science is there, but you really have to understand it, because that is the basis of good biotech patents. Additionally, if you want to become a patent attorney or a patent agent, you must enjoy writing. You're going to spend not your entire life, but you will be writing a lot. 10, 12 hours a day. You must be able to write, because you're taking people's ideas, you are reducing them to a written form that follows certain legal obligations. You will need an understanding of patent law, but if you have the first 2 points, if you have the knowledge and passion for science and are able to write well, you can easily get trained in understanding patent law. This is not brain surgery. This is very straightforward legal issues for the most part. And where do you get this type of training? Typically, people with PhDs will join a law firm as a scientific advisor and will get on-the-job training in writing patents and also in the patent law that they need to know. Typically, you'll need some additional training or some additional exams, I guess would be. And that would be, you can either take the patent bar, which is an exam. You do not have to be a lawyer to take the patent bar, but you would become a patent agent. And a lot of people who work for patent law firms ultimately go to law school, often part-time, and will get a law degree and become a patent attorney. Good patent attorneys, like good tech transfer people, in the biotech field are in high demand. And these people can work at a patent law firm or in-house. By in-house, I mean either in-house in a corporation or also even in-house in a larger tech transfer office. What are the personality characteristics? And these personality characteristics, to me, underlie anyone who will be doing a really good job in either tech transfer or patent law. I cannot emphasize enough, you must love science. Very importantly, you must be able to think creatively and strategically, because you're going to be looking at how do you apply basic science to commercial applications. Right. And what I always tell our scientists when they're thinking about inventions is I want you to use inductive logic instead of deductive logic. All right. I know when you're, as an academic, when you're standing up and talking about your findings, we're always very careful not to claim more than the data supports. Very careful. You know, we have reason to believe that this could be the mechanism, but not really to expand beyond what your data says. The exact opposite is true when you're thinking about how to take a finding and make it into a technology. You really want to think about all the possible applications and claim those in your patent, because that's where this is your chance for really broad kind of creative thinking. And so, as I said, you really need to think outside the box and use your intuitive logic versus your deductive logic. It's very important that you be able to write and clearly and easily. And even in my office, I don't write the patents, but I spend a lot of time communicating with people by email. And these, so being able to write is very important. You must be entrepreneurial. And what do I mean by entrepreneurial? Really self-driven, really thinking outside the box, and somebody who, when they find an obstacle, is going to look for a way around it. One of my favorite quotes comes from Jeffrey Katzenberg, who says, if you can't get out the front door, try the back door. Try the side door. Try the back window. You're constantly going to be coming up with obstacles, people telling you can't do this. And your job is to get that out there, to get the license done, to get the patent done. So we're really looking for people who are entrepreneurial and creative and just will think about creative ways of overcoming obstacles. Also, you have to be comfortable dealing with a wide variety of people. You're going to be dealing with scientists. You're going to be dealing with business people. You're going to be dealing with lawyers. You're going to be dealing with clinical people. And so it's very important that you have very good people skills, very good speaking skills, and just really, being comfortable dealing with a wide variety of people. To me, all of these things are what makes the job fun and interesting. So getting back to my little Venn diagram, I would say that while technology transfer really incorporates multiple disciplines, your knowledge, your background in science is really critical and is an opportunity to now build on that if you're interested in a career in this area. Okay, so hopefully I've sold you. And if you're interested in this, now what? Okay. Well, I want to talk to you about 4 resources that you'll find useful if you are thinking about a career in technology transfer. The first 2 are 2 professional organizations. So what ASM is to microbiologists, AUTM, the Association of University Technology University Technology Managers, is the organization that I belong to, that I am active in, and where I have gotten a lot of my formal and informal training. The other professional organization for technology transfer is the Licensing Executive Society, and I'll talk a little bit about both of those. One fabulous resource for training in technology transfer is NIH, and the other resource for training in technology transfer is actually your local technology transfer office. So let's talk a little bit about AUTM. As I said, AUTM is the professional society for university technology transfer people. It was founded in 1974. It was called the Society of University Patent Administrators, very narrow focus, and with 7 members. It's a little bit bigger today. Today we have over 3,500 members, representing over 350 academic institutions. And these are academic institutions worldwide. I would say about 250 are U.S. academic institutions, and we have many, many members who come to AUTM from all over the world to learn how we do tech transfer in the United States. And as a result, AUTM has now established many branches outside the U.S. Additionally, about 1/3 of the AUTM membership are people from industry. These are the business development licensing people from industry, who they're the ones who want to learn about what's going on in the academic institutions, like the Wistar Institute, and also want to learn how to deal with the academic institutions, because they have to deal, like we have to deal with our lawyers and our obligations, they have to deal with their lawyers and their management. So these people join AUTM to learn the academic perspective on technology transfer. And AUTM really provides both professional development and networking opportunities for tech transfer professionals at all levels. They have a variety of resources. Okay, they have an annual licensing survey. This is a very important metric that we report every year because, again, most of what we're licensing was developed out of your tax dollars. Provide excellent training programs, some wonderful publications, including the Technology Transfer Manual. This is like a Bible. This is like Maniatis to the technology transfer world. We have annual meetings and regional meetings, and at these meetings there's a lot of interaction to meet and learn from colleagues. And Autumn is just an incredibly collegial organization. Even though these people may in some ways be your competitors, it's an extremely collegial group. Autumn also has special topics of interest to members, licensing for public health, managing a small office, things like that. So it's just a phenomenal resource. The other professional organization is the Licensing Executive Society. This was established in 1965 and has over 6,000 members who develop, use, transfer, market, and manage intellectual property. Intellectual property, that's patents, proprietary business materials, copyrights, software. The members there include business development and legal professionals, and the LES resources include many meetings as well as local meetings. And if you join LES, there's usually a monthly local meeting, which again is another place to meet with people and learn from people. LES has a little more emphasis on legal and corporate licensing issues, so as a university tech transfer person, I'm more active in Autumn than in LES, but they're both very good organizations. And they also have many training programs. So if you want to get training to become a tech transfer professional, where would you go? My recommendation would be the first place would be to go to your university's tech transfer office and go and talk to them, find out what they do, and also find out if they have any openings for apprentices or interns. Many of the larger universities have formal apprentice programs because, again, we're always looking for good people in this field. And the best way to get trained is just like a postdoc, is just to get in there, work with good people, and do it. Additionally, I would encourage you to support the training by Autumn or LES courses, and these have excellent courses in the basics of technology transfer. I'm going to talk a little bit about NIH training programs. They have some excellent training programs. And another way would be to join industry. I know many people who joined industry as scientists in the R&D department and then transferred over to business development, licensing, alliance management, and have subsequently then gone back to the university to use their training that they got in industry to help the universities transfer technology. Let me talk a little bit about the Autumn courses. These are offered once every year. And Autumn offers two phenomenal courses. One is the basic licensing course, and this is really for people who are new to tech transfer. Before I got my first job in tech transfer, I took this course, and it was like, wow. They have all these wonderful workshops, and they really follow the life cycle of a technology. I've talked about here's what we do, but they actually take a technology, and you follow it through the disclosure, through the agreements, through the licensing, through the marketing. And so that really gives you a whole foundation for the licensing process. Additionally, Autumn has a course called Tools, which is the Technology, Operations, and Organization Licensing Skills. The Tools course is really more for administrative and support staff, but it does give you a good background in the tech transfer vocabulary, what is a material transfer agreement, what is a corporate research and development agreement. And it also focuses on compliance issues. I've not gone into it a whole lot, but again, because we are funded by federal government, everything we do in our tech transfer office has to get reported back to the federal government, who then goes and reports all the successes back to Congress, who will hopefully then appropriate more money that we desperately need to do our academic research. Autumn has several other resources. The Technology Transfer Practice Manual, again, this is like your Bible on policies, procedures, agreements. I would encourage anyone who's interested in the field to look at the Autumn website. It has a lot of links to resources on patenting, licensing, NIH guidelines, as well as international organizations. The Autumn website also has job listings, so you can see who in your area is looking for people in tech transfer and what type of people they're looking for. Autumn also has the national and regional meetings, programs on anything from basic to advanced topics. I've been running a tech transfer office for 10 years, and I still learn many new things every time I go to an Autumn meeting. They also have special interest groups and just a phenomenal opportunity to exchange information and best practices with your peers. Additionally, the Licensing Executive Society has some very good training programs, actually excellent training programs. They have one that's called the Professional Development Series. They divide this into fundamental, intermediate, and advanced. They call it intellectual asset management. These programs are typically 3 to 4 days, and they are approved for CLE credits, which is mostly for those of our colleagues who are lawyers and need to have a certain number of CLE degrees. Additionally, LES, in conjunction with BIO, this is the big biotech industry meeting, has a BIO LES business development courses. And so what a lot of times what will happen is people like myself will be at the BIO meeting, and then you get to take this course at the same time. LES also has many technology transfer seminars, as well as regional and international meetings and workshops. So again, if you're interested in learning more, these are both two excellent organizations to get the training you will need. LES, among their other resources, is their website. That contains a lot of links on publications, IP, licensing, information on their meetings, and as well as membership in the local chapters that usually meet monthly. About 3 weeks ago, I was at the BIO meeting, and I started talking to a colleague from NIH. And we were actually in a session on cancer stem cells, and I learned that he was a postdoc who had just transferred into tech transfer. And I said, well, how did you do that? And he said, well, there's NIH training programs. So in preparing for this talk, I actually got to learn about several phenomenal training programs that I did not know existed. So let me share them with you a bit. NIH has two types of training programs. The first is actually through NCI, and these are called Cancer Research Training Awards. And these are actually a program that provides advanced training in what they call state-of-the-art techniques of technology transfer. These are training awards that have yearly stipends, and as well as giving you training in technology transfer. You must have a background in science, and not just cancer, but any area of science, and an interest in technology transfer. And I've put here the link. And just to let you know, if anybody would like copies of my slides, which have all these links in here, just let me know. I'll have my email up at the end, and I'll also have some business cards. If you want to just send me an email, I'm happy to send you the slides. Additionally, so in addition to the NCI program, the NIH Office of Technology Transfer actually has fellowships in technology transfer. And these are in two areas. One is metrics and marketing, and the other is in the agreement negotiation. So the NIH Office of Technology Transfer, these are actual postdoctoral fellowships in technology transfer. And they're called the Technology Transfer Research Training Awards. Of course, this is NIH, so you have to have a bunch of letters. But they're really to enable you to combine your background in science with training and expertise in the tech transfer field. Because these are actually fellowships, everyone has to spend 20% of their time actually working in an NIH lab, but then 80% of your time is spent at the Office of Technology Transfer. This is a 2-year program, and I will tell you, NIH's Office of Technology Transfer is one of the premier offices in the world in this area. People come from all over the world to see how they do it. The other premier offices are Stanford, MIT, and Harvard. These are the ones who are really the leaders in establishing technology transfer. So if you get a chance to work in this program, you will be extraordinarily trained. I can tell you that 2 years ago when I was looking for somebody for my office, I called a colleague at NIH and said, okay, who do you have who's coming out of one of your fellowships? Now, several people have always asked me, well, okay, if I really want to go into technology transfer, should I get either a business degree or a law degree? You know, I have a science degree. Don't I need an MBA, or don't I need a law degree because I'm going to be negotiating all these agreements? And my answer is, it doesn't hurt, but it's not necessary. I do not have either advanced degree, but I would put my knowledge up against some of these degree holders with anybody, and this is just knowledge that I have gained from working with some really, really sharp people over the years. So as I said, it helps. You can very often get an MBA or a law degree while you're working if you wish, but I wouldn't consider it essential. I'm coming to the end of my talk now, and I know in scientific sessions everyone always thanks the people who contributed to the work. So I just really want to thank all of my colleagues and people who I've learned from along the way. At Autumn, LES, other universities, colleagues at Wistar, colleagues in industry, and what I call my WISE Patent Council. If you have any questions, and I know we're going to have an extensive Q&A discussion at the end, you're more than welcome to send me an email. Here is my email address. And, whoops. Okay, I guess it's over. Thank you all very much.